Algebra 2, Concept 6B. We're going to continue looking at transformations of quadratic functions, but in 6B we're going to look at vertical stretches and shrinks. In 6A we looked at horizontal and vertical translations. Let's get down some vocabulary. Remember, pause the video if you need to get the definitions written down. So, reflection in the x-axis. This is a flip of a graph, and we're going to be graphing parabolas over the x-axis or a horizontal line of reflection. A vertical stretch is a stretch away from the x-axis. The graph will narrow, so our parabola will become more narrow or skinnier. A vertical shrink, sometimes this is called a compress, is a stretch down towards the x-axis, and in this case the graph, the parabola, will widen or flatten. Now, to see these transformations in action, we're going to graph some quadratic equations like we did in the last concept. So we're going to graph the parent function just this once. I think we'll actually do it wherever the directions say. So remember, the parent function is y equals x squared. And then we use those very basic negative, 0, and positive values, and we're just squaring them to get our y values. And so on your graph space, you're going to draw your xy axis and make sure that you label that always, and then label a scale. And you'll need to do this when you complete your unit study guide in your exam to get full points for your graph. And then we'll graph those points. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And then that nice smooth U-shaped curve with the arrowheads. Alright, so that's our parent function that we will compare our new function to. And that is f of x, or y, equals 2x squared. So write that in your table. Now, we're going to think like we did in the last section in vertex form. So I will write that, and you can write that down again. So our function equals, it's a times x minus h quantity squared plus k. So I'm looking for my h and k values in this function here, and I notice that nothing is being added or subtracted to the h value or added or subtracted to the n. So that means my h value is 0 and my k value is 0. So the vertex is 0, 0, and I'm going to put it in the middle of my table. And then I'm going to step 2 values in the negative direction and 2 in the positive direction. Now I'm going to plug them into my equation for x. So negative 2, and order of operations tells us we need to square first. So negative 2 squared is 4. 4 times 2 is 8. Negative 1 squared is 1. And then 1 times 2 is 2. 1 squared is 1, times 2 is 2, and 2 squared is 4, times 2 is 8. So I'm going to graph this in red so we can see our transformations like we've done before. So negative 2, and now it's going to stretch up to 5, 6, 7, 8. Whoop, there we go. And then negative 1 is going to stretch up to 2. It's going to hold there, 1, 2, and then 2, 8. And then a nice smooth U-shaped curve. Now we're going to describe this transformation, and we're going to use one of our vocab words. And so this will be a vertical, and it is narrowing. I'm going to abbreviate here. So we're going to call this a vertical stretch. And then our vertex we have identified as 0, 0, because those are the h and k values in the equation. Now let's graph a function that has something a little different going on. First, it says graph the parent function. I've done that already, so pause the video. You should be getting really good at that now, and just use those typical values that we did in the first example, and then come back. Okay, now let's write our equation in our table here. So negative 1/2 x squared. Let's identify the vertex. So our h and k values are what are being added and subtracted. And we can see that nothing is being added or subtracted by the x or to the n. So once again, we've got a vertex at 0, 0. We're going to place that in the middle of the table. Then we're going to step 2 steps in the negative direction and 2 in the positive direction. Now when we plug in our values, we're going to take negative 1/2 times negative 2 squared. If you put it in your calculator like this, it will do it in the right order for you. If you're doing it in your head, remember exponents go first. So negative 2 squared is 4. Half of 4 is 2, but then we need to make that negative. And then we'll have plug negative 1 in, square it, we'll get positive 1, times negative 1/2 will be negative 1/2. And I'm just going to write that as negative 0.5. If I plug in 1 and square it, I get 1 times negative 1/2 is negative 1/2, or 0.5. And then I bet you can guess what this value will be. 2 squared is 4, half of 4 is 2, and then we need to make that negative. All right, I'm going to graph in red. So negative 2, negative 2. Negative 1, and then I'm only going to go halfway. So I'm just going to estimate as best I can. Positive 1, and then positive 2, negative 2. Now a nice smooth U-shaped curve, and you should see that this U-shape is a bit wider than the original. And so what we have here, it is also opening downward. So we have two things happening. We have a reflection in the x-axis. So we're going to describe the transformation, we're going to say a reflection in the x-axis. And that's the first definition that we covered in these notes. And then the second thing that we see is that we have a vertical shrink. And that's when the graph is getting wider. Our vertex, just like the others, was at 0, 0. Now we're ready to write some rules for vertical stretch and shrinks and reflections. So in your notes, you're going to go and fill in the blanks. So when the absolute value of the a value in the function, and let me just write that function up above, and you can do this in your notes too, just to help you remember where those numbers are that we're talking about. So your a is in front, h is here, and then k. So when the absolute value, and that means we're ignoring whether it's positive or negative, we're just looking at the positive value of it. If it is greater than 1, then you're going to have a vertical stretch. So that graph will narrow. When the absolute value of a, and what you need to fill in the blank is in red here, is less than 1, it is a vertical shrink. And then the graph, as you saw when we graphed it, widens or flattens. If the output is multiplied by a, and then the value of a is either negative or opposite of the original function, it's an x-axis reflection. And so that's why we saw the graph flip over the x-axis when we went from the parent to this function. That negative sign caused it to reflect. And then this value caused it to widen. So we had both a vertical shrink, hopefully I said that right, vertical shrink, and an x-axis reflection. So now you're going to do the independent practice. Pause the video, graph those and answer those questions on your own, and then come back and you can check your answers. Alright, welcome back. Now compare your answer on number 1 to what I've got here. Hopefully as you got those values for this equation, you noticed that you had a negative in front, so you knew this graph was going to flip over the x-axis, and then the a value is, the value of it is 2. So it's going to be skinnier than our parent function. So we have got a vertical stretch situation. So your graph should be opening downward. It should have its vertex at 0, 0, and then have its points so that when you draw that U-shaped curve, it is skinnier than the parent. And up in the upper right, I have our transformations written. It is an x-axis reflection and a vertical stretch. And our vertex is at 0, 0. All right, check your answers on number 2. So A, we've got -4 times x plus 1, quantity squared minus 5. So I have identified A, which is -4, and if we graph this equation, that would cause an x-axis reflection and a vertical stretch because the A value, which is 4, is greater than 1. Our H value, it's opposite of what you see there, so it's -1, so we would shift to the left 1, and then our K value is -5, so it'd be down 5, and then the vertex is the HK. And then for B, our A value is 1/2, and so that's just a vertical shrink because it's less than 1, the value of it. H is 1, so it's going to translate to the right 1, and K is 0, so your vertex is at 1, 0. Okay, and lastly, number 3. So now you're going to write your own function. So A, you want a reflection over the x-axis, and for that quadratic to be shifted down 3. So you should have a negative in front of the x squared, the A value, and then a -3 at the end of the equation. That's your K value. And for B, you want a vertical stretch by 2, so that'll you'll want to have an A value of 2, a reflection over the x-axis, so I'll highlight these. So we've got a -2, and then a shift that's to the right 5, so that means you're going to subtract 5 for your H value, and then shift up 2, so a K value of 2. So when you're given these and you need to build an equation, just think of that general form of y, or f of x, we usually have it in function form, equals a times x minus h squared plus k, and then just put the appropriate values that you need in those locations. Now you're ready for the teacher talk.